Hello, this video is about performance and measuring performance in the Python programming language. This video will show you tips, tricks, and techniques of how to take your Python code and see how fast it's running. In order to understand performance, you have to understand what it even means to measure performance. Performance is not a time or a date, it's an interval of time, meaning from some time t1 to t2 or to t3, what is the amount of time between those points? And that's exactly what I'll teach you how to measure in Python in this video. The module we'll be using is called the datetime module. This module contains several classes, such as the time class, the time delta class, and the datetime class. We'll be mostly using the datetime class and the time delta class. Basically, the datetime represents points in time, and the time delta is the differences between those points in time. So here's an example of how you use the datetime module. You create 2 points in time, A and B. You subtract A from B because B is the later time. And then you can print like the microseconds or the seconds or even the days within that interval. The whole point of it is that the interval is represented by the time delta, and it's just an amount of time. It's not correlated to specific points in time, it's just an amount of time in different units. And to build on that a little bit more, I'll emphasize that the delta does not correspond to any date or time or any calendar time or anything like that. Like you can take it from a time zone of this time, this place, or a different local time or GMT time or UTC time. It's not affected by the time zone or anything like that. It's just an amount of time. That's all it really is. So to demonstrate performance measuring and testing, we'll use this simple function called the factorial function. So the factorial function represents a series of integers that are all multiplied by each other, and it goes from 0, 1, 2, 3, 4, 5, 6, and so on. And this specific function uses recursion to calculate that. That does have an impact on the performance. Usually recursion is slower than iteration, but we'll just use a very simple function like this to demonstrate performance. This is the code I'm going to use to actually time the factorial function. First, I have a general sort of like timing function where you take in a function object and the argument. You start one point in time, you run the function, you take the delta of when it completes versus when it started, and you print it out in microseconds. The reason we use microseconds is because we want a very precise measurement, and some of these functions can be very quick, and so something like milliseconds or seconds wouldn't get that delta. Then I have another function abstracted on top of that just to get the measurement within a range, like 1 to 10. I want to see all of those performance times. Here are the results of running the test. It shows a pretty interesting pattern. To calculate the factorial of 1 actually took the longest versus the others, which are quite faster and sort of got a little bit longer towards when you get to 10. One possible reason for the 1 taking the longest is it uses an if statement without any recursion optimization that the Python interpreter can do. The interpreter actually has this ability called a tail call optimization for recursive calls, but if you only have one if statement, that won't really take place or happen because there's no recursion. That's about it for this video. I'm looking forward to making a lot more videos on performance and Python and the different trade-offs of what can affect performance, so stay tuned.